So for today's assignment, we'll be explaining the basic principles of the basic equation of statics, which is dP, which is displacement and pressure, over dz, which is displacement and distance, equals negative rho, which is density, times g, which is gravity. To start this off, we have to go a little backwards, and we have to start with the force balance equation. And so with that, we say that F equals ma from Newton's third law. And from there, we can substitute in variables for ma, and we say that F equals gravity times rho, which is density, times area, times displacement, distance, and these two form the volume. And with that, we know that pressure equals F over A, so force over area. And with this information, we can then substitute and say that the pressure at Z times area minus the pressure at Z plus the displacement minus rho G area times displacement equals 0. And from there, we can say that the pressure, the change in pressure equals rho G all over dz. And then from here, that's where we can say that this, which is delta P, that's an A, we can say that delta P is equal to this displacement over this displacement, which equals our negative rho G, and that gets us back to this first equation. And so from there, we can take this first equation and apply it to a scenario like a piston where the lid is moving down. We can say that this would be Z1 and this would be Z2. And so for this case, we'd say that dP again over dz equals negative rho G. We got to move dz to the other side over here. So multiply by both sides, and then we'll have dP equals negative rho times G times dz. Then we're going to take the antiderivative of both sides. This from P2 to P1, this from Z2 to Z1. And then from there we have that P from P2 to P1, and we can assume that P1 is the absolute pressure. So that's 101, 325 pascals. And that's equal to negative rho G Z, and that's from negative H, which is the distance, to 0. And so from there, we can say that P2 minus 101, 325 equals rho G H. The negatives cancel out here. And from there, we can add this 101 over and say that P2 equals 101, 325 plus rho G H, essentially saying that pressure equals density times gravity times distance. And so here now we take the ideal gas law, which is PV equals nRT, and we substitute the variables in to make it work for this scenario. So we say that rho equals P times V over RT over N. And this V and N becomes the molar mass, which we can represent with the letter M. And so now our equation, if we substitute it in, says that dP over dz equals negative P times M over RT times G. And so we bring the dz back over again. Let me flip the page. And then when we do that, we have that dP equals negative mg over r T times dz, and we can bring the P that was here first over here and say that's 1 over P. And then we take the antiderivative again, so from P2 to P1, and this is from Z2 to Z1. And then we end up with the natural log of P2 over P1 equals negative mg over RT times Z2 minus Z1, which is delta Z. And so from here we can say that P2 equals P1, the exponential of the exponential raised to the negative mg times delta Z all over RT. And so from there, with this final equation, we see that pressure is equal to really the ideal gas law and change in distance. And so for our scenario, we're assuming that temperature staying constant, we can assume that all these other variables stay constant except for this P1 and these delta Z. So an example to find things, we could say Z2 equals negative 10 meters and Z1 equals 0 meters. And so we can show that P2 equals, we'll say the 101, 325 pascals times e to the, we'd have negative 10 minus 0, so that'll be negative 10. And we say that P2, if we plug in the calculator, P2 is equal to, let's see, that's equal to about 4.60 pascals. And so if we take another scenario and we say that Z2 equals negative 20 meters and Z1 still equals 0 meters, do the same thing. We'll have P2 equals 101, 325 pascals times e to the negative 20 this time. And if we do that, we plug in the calculator and multiply that. Then we have that P2 equals less than what it did before, about 2.088 times 10 to the negative fourth. And so this shows that as the distance grows larger but becomes more negative or decreases, I guess you can say, the pressure becomes less. And so if you think about the piston idea, you think this pressure is, there's less area, so the pressure has less room to work with.